This video goes over the Chapter 9 PSAT problems. To find the area of this figure, we divide it into a square and a triangle. 4 times 4 is 16 on this other side. We have 3 times 4 divided by 2, which is 6. Add them together, the answer is B. Height of 4, distance of 3, 4 times 3 divided by 2. So here is a circle with a square inscribed in it. That means that these corners are on the circle. And since the radius is 6 root 2, that means that we can create this triangle here with distances 6 root 2 and 6 root 2. So if I pull this out, this is a 45-degree angle, which means so is this. And since this is 6 root 2, that means this is 6 and this is 6. So is this. 12, 12, 12, and 12. The perimeter is 48. This is a tough one. Regular hexagon has a side length of A. I divide that into 6 equal parts, and I draw a line down the middle. My central angle is going to be 60 since there's 6 of them. So this angle is 30. Let's draw that triangle out here. Angle of 30, this is 90, this is 60. Any of the side lengths were A, but I'm only taking half of that, so it's going to be A over 2. That's across from my 30-degree angle. Across from 90 then is going to be A. And across from 60 is going to be A over 2 times root 3. That's my apothem. If I want to figure out my perimeter, it's just A multiplied by 6 times. So 6A is equal to my perimeter. Let's plug all these into the formula. The area of a regular hexagon is the perimeter times the apothem divided by 2. So if I plug it in like this, I can double 768 root 3 is equal to, let's clean this up a little bit, 6 over 2 is 3a squared root 3. So if I divide, I'll just get rid of the root 3's by the way, and I am left with 256 is equal to a squared. So 16 is equal to a. So now the area for a square is just a squared, which is back to 256. The answer was A. The old radius is 0.3. I'm 11% larger, so 0.3 times 1.11. My new radius is 0.333. We're looking for circumference, so that's 2 pi r. So 0.33 times 2 times pi. They want us to round to the nearest tenth, I think. That's going to be 2.1. Another 30, 60, 90 problem. If that is 12 across from 90, then across from 30 is 6. So this one is also 6. To enlarge the dimensions, we can't start with 5 and 7. We have to start with the area 35. And 250% of that is times 2.5. Times 2 would be 70, and then a little bit more, so 87.5. So in this one, they tell us that BC, this entire triangle, is 15, and that DA, this smaller part, is 4. And there's this tangent ratio for angle B of 3 to 4. So if I'm looking at angle B here, the tangent of B is equal to the opposite over the adjacent. So this is going to be the opposite side, and this whole thing is going to be the adjacent side. So I'm trying to come up with two sides that have a ratio of 3 to 4. So I could choose 3 over 4, I could choose 6 over 8, I could choose 9 over 12, and I'm also trying to figure out to make that a squared plus b squared is equal to 15 squared, since 15 is my hypotenuse here. So these are going to be the ones, 9 and 12, which means that this distance over here is 9, and this larger distance here is 12, and that means that this is 8, and they want to know what DE is. So we have a ratio. We can say something like 8 is to 12 as x is to 9. That would be one way to find the answer of 6. There's other ways to set that up. So we have a container that didn't account for cushioning, so we didn't make it bigger. The original area was 12 times 9, so 108. We want to have one that's 25% greater, so we multiply by 1.25. That's 135, the new area. Here we have a radius of 10, so that means that these two values are 10. I can turn this into some 90-degree angles. That'll cut this in half. I know that this distance all the way across from 4 to 20 is 16, so half of that is 8. So 10 squared minus 8 squared is equal to this height, k squared. 100 minus 64 is 36, is equal to k squared. 6 is equal to k. So we know a couple things. If this is 4 and this is a hexagon, we can do this where we say this is 2, this is 30, and this is 60, and this is 90. Across from 30 is 2, across from 90 is going to be 4, across from 60 is going to be 2 root 3. So that tells us this height over here is 2 root 3, or this one over here. And the same thing can be done in all 4 of the triangles. It has a height of 2 root 3. And now we need to figure out this other part of the triangle, which isn't too bad, because if you think about this triangle, well, this side length is 4. So we could just jump straight to Pythagorean theorem if we wanted to. If we had a calculator, that would allow us to calculate that this is 2. They want to know the sum of the areas of the 4 triangles. So 2 times 2 root 3 is 4 root 3. I divide that by 2. 2 root 3 times 4 gives us our answer, 8 root 3. So we have a couple pieces of information here. We know that our hypotenuse is 10. One of our legs is 8, so the other leg is going to be 6 on both sides. So then 12 times x is the area of the seating, which is 180. 12 times x is equal to 180. So that means that dimension is 15. 3 is to 9 as 5 is to 15. And if I have 2 sides of a right triangle as 15 and 9, I can square them, add them together, take the square root. So the hypotenuse is the square root of 15 squared plus 9 squared. If I round that to the nearest tenth, I have 17.5. To find the perimeter, I add 15 and I add 9. And the answer is 41.5, C. Based on the properties shown here, this is a kite. And we know a couple of things. We know that BE is 2, so is ED then. So this entire distance across is going to be 4. But let's start with just 2. We know that BC is 4, so this is a 90-degree angle. We can figure out EC based on the Pythagorean theorem, the square root of 4 squared minus 2 squared. So that's the square root of 12, which if we change that to the square root of 4 times 3, we can pull that out as 2 root 3. Now they also tell us that AC, this entire distance, is 10. So we're starting to figure this out. If this is our triangle ABD over here, the base is 4, and the height is going to be whatever 10 minus 2 root 3 is. So I have 4 times 10 minus 2 root 3 all over 2 is equal to the area. So 4 over 2, this is just going to double that, and it's 20 minus 4 root 3. So it's C. 4 over 2 simplified to 2, distribute, 2 times 10, 2 times 2. Base times height is 50. Ignore the 5.25. So this is a fence around the garden problem. The length is equal to 9 feet less than 3 times the width, 3w minus 9. And the width is just equal to the width. So if I take w times 3w minus 9, I get 5,670. Yikes. Honestly, I think if I got to this part, I would probably just start guessing and checking. But I suppose you could use something like the quadratic formula. And if I did that, I would get 3 plus or minus the square root of this larger number, which turns out to be 87 divided by 2. Or excuse me, this whole thing is over 2. So that's either going to be 84 or 90. If I divide that by 2, 42 or 45. Let's try some of these, plugging them in. And if you guess and check, it turns out 45 works for W. They want to know the perimeter then. So if this is 45, and this other one is 45 times 3 minus 9, 126. Our answer is 342. You just double the length and the width. We're designing a rectangular fountain as a 4-foot wide path around it. Here's the formula we have. Notice the slope is 4. So every time the p goes up by 4, a will go up by 1. Every time p goes up by 1, a goes up by 1/4.